Hi everybody, welcome back to Utah. My name is Dave Vellante, and I'm in the house with Rebecca Knight, and you're watching theCUBE's live coverage of VAST Forward 2026, the inaugural VAST Customer Conference, made possible by Solidigm. Super excited to have a great round of guests here on our panel. To my right is Andy Pernsteiner, who's with VAST. He's a field CTO, CUBE alum. Good to see you, Andy.
Yeah, great to see you, Dave.
Eric Bermender is here. He's the manager of data infrastructure and platform at Pixar Animation Studios. AI is changing everything, including entertainment, and Ace Stryker is back. He's with Solidigm. Thanks for your support today. Appreciate you guys sponsoring us. Eric, good to see you. First time on theCUBE, I believe?
Yes, right? It is. Thank you very much for having me.
Yeah, you bet. Well, let's start with Pixar. 1986, I think, is when Pixar was founded. Toy Story, you know, the
Toy Story came out in '95.
Right.
In '86, Steve Jobs bought it from George Lucas.
Yep.
And that began our road into computer imagery.
So how has, take us through the sort of timeline and evolution of that that computer imagery from a technology standpoint. Yeah. What's the state today?
You know, it's interesting because we started out as a computer company, unlike a lot of other companies at that time that were doing more visual effects type work, so trying to make special effects for movies. We started out with the idea of, we're going to do everything in the computer. So for us, this journey that we've taken for the last few decades has been a continuous journey. In other words, all these new technologies that have come out, and over time, we'll take advantage of them when we can in order to help our artists iterate faster. And so the latest technologies that are coming out are just the next round of trying to figure out how to implement that in a way that makes our artists' visions like realized.
So I got to ask you a question. So, you watch Jensen Huang's keynotes, right? And he always has these amazing graphics behind him, and he says every pixel, and these were inferred. What's actually going on as a expert in the industry? Right. Explain to we lay people what we're actually seeing there and what it means to a firm like yours.
Yeah, so traditional computer animation, we will build 3D models and we'll texture them and then we'll rig them up. We move Woody and Buzz around the scene, and we do this process called rendering. So you take all that information, you run it through a render engine, in our case it's RenderMan, which is a product we make, and then pixels come out the other end. And our artists, what they want is to have control over all those pixels on the screen, like very fine detailed control of what you're seeing in every section of any given image. When Jensen's talking and he's got inferred pixels back there, one of the challenges with these newer tools is the ability to control those exact pixels, right? Because an inference engine might make an image one way one time and then make a totally different image the very next run.
Yeah, right.
And so that's one of the challenges that we have, is how do we get the ultimate control over all that data?
Got it, okay, so it's like, your artists want deterministic,
Very much so.
We want this repeatable pattern. It's like when you ask AI, no, do it the same way, and it doesn't. And you say,
that's exactly.
And it's really frustrating. You actually spend more time trying to figure it out. So they want to be able to turn the knobs and control those pixels, whereas we're now entering a world of probability and inference.
Yeah, exactly. And it isn't that we can't use that technology, it's just like, how do we incorporate it into the tech we already have? Our features will tend to take 5 years or so from beginning to end. And so you don't want to change the tech out right in the middle. So typically what'll happen is new tech comes out, and then we will then incorporate that new tech into the next feature that's going to be in development.
Okay, so then why do you need these guys? Why do you need VAST, the AI expert here? How do you use VAST, and how do you apply that AI?
So we first ran with VAST for a feature called Soul. And what we needed was volumetric characters, which, not to get too detailed, but the characters are created in such a way, it was a new way of creating characters, and it needed lots of capacity and very high performance. And before that, we were dealing with tiered storage structures where you'd have like the small flash layer, and then you would have multiple tiers of storage behind it. It was very difficult to envision how we could create these new characters on a very small flash tier. So we engaged with VAST. Their premise of, at the time, it was universal storage, disaggregate storage, where you just have one layer of data storage that's all flash, super high performance. I no longer have to worry about the aggregate being the problem. And in order to handle all the IOPS, these renders take a lot of processing power, but also put a lot of pressure on the file storage because it's a whole bunch of small file writes and reads.
Right.
And so we could expand out that compute layer on VAST as big as we needed it. We did not have to couple the capacity growth and the compute growth together as in like one single appliance. And so that's why we started with VAST and why we've continued to expand.
So Andy, your role is to help clients like Pixar optimize the platform, right? Maybe you describe that a little bit,
Yeah,
and maybe the history of your relationship.
Well, the history actually is that basically the first day I started working at VAST, we started talking to Eric. And they had a system before we even had a GA product, right? So they've been a co-developing partner with us since the very beginning. Since 2018, we installed what we called our alpha code. Back then, we didn't have high availability, we didn't have any bells and whistles, it was just there. And so through that process, Pixar has obviously put more and more workloads on us. There are actually some major features within the platform that they specifically influenced. The first example, or the main example, is our CNode pool or VIP pool feature. And maybe Eric, you could kind of explain what you use that for and why.
Yeah, sure. So we have a lot of different pipelines that get hot at different points throughout the production process. And sometimes we'll have a pipeline that needs a whole lot of storage compute for like, let's say a burst of time, like a month or something. In the old days, we used to physically have to move nodes in the data center from one cluster to the other to try to accommodate that. What we asked VAST for was the ability to carve up our C nodes into different VIP pools, so different groupings of at the network layer that we can then point our mounts to, and then we can dynamically expand those just in software as needed to support any given workflow that might need higher performance at any given time.
So you're not doing all that heavy lifting and reconfiguring and fine-tuning.
It was great.
Okay, so what other requirements that you need from Ace and from storage?
Yeah.
I mean, being in the storage business, that's where I kind of started my career. Three things are immutable in storage or requirements. I want it to be rock solid, lightning fast, and dirt cheap. And,
well, yeah, there's that.
And there's always that trade-off, right? So what do you need from folks like Solidigm?
Yeah, so the flash layer, the reason why the flash layer is very important to us is because latency is one of the, is what our artists are most sensitive to. So they're doing stuff in real time at their desktops, visualizing these different components that they're working on. The performance has to be guaranteed. Like we have to hit a certain less than this millisecond latency in order for the artist to feel like they're iterating at the speed they want to iterate at. So that's the biggest thing we need from this layer of flash is guaranteed latency, no matter what kind of render loads we're also putting on the systems at the same time.
So that's the lightning fast piece, but there's a cost to that. So how are you helping the other piece of my threesome, which is the dirt cheap? And notwithstanding, again, I know there's supply constraints right now, but it's all relative. So what are you guys doing to help Pixar, make it lightning fast and help deal with the costs?
Yeah, it's a good question, Dave, and it's an interesting time in the market to be talking about the cost of getting this done and sort of optimizing for cost efficiency, right? Because the reality is there's this AI explosion going on that's really driving up demand for DRAM and NAND at unprecedented rates. And so the name of the game has really been, how do you do more with the resources that are available to us, right? And from a Solidigm point of view, that involves kind of fine-tuning the product roadmap to make sure that we have different swim lanes of products to serve needs, and be able to deliver as much as possible to the market in a constrained environment. So as an example, not to geek out too much in storage, but we sort of have performance-oriented drives that are built on what's called TLC NAND, and we have sort of capacity and efficiency-oriented drives built on QLC, which VAST incorporates into a lot of its systems, right, and its solutions that it sells. So by working with VAST and sort of worrying less about making a great SSD and making next year's 10% better than this year's, and really asking the question of how does this exist within a solution, right? And how does it work with the other resources in the solution to deliver optimal outcomes to an end user like Eric and the artists at Pixar, right? We can make the right choices and we can deliver optimal value. And that's really what it's about at the end of the day. It's kind of fun, you've got virtually the whole value chain here, right? Eric's job is removing obstacles for the artists. Andy's job is removing obstacles for Eric. Solidigm's job is removing obstacles from Andy from a hardware perspective, right? So when we all work together with the end user in mind, we can make sure that we understand kind of optimal outcomes, and we're all rowing in the same direction, if you will.
You're still tiering in a way, right? But you're managing the tiering.
Actually, there is no disk tier anymore.
Well, no, but the QLC is a form of tiering, is it not? I mean, a less expensive flash is or a NAND, but you're managing that. You don't have to do that heavy lifting, is that right? Or?
Yeah, I mean, from the user standpoint, it's completely transparent.
Right.
We do use different types of flash in our platform.
But that's automated, right?
It's automated, and the latency and performance that we advertise for the platform incorporates all of that. And we've taken a unique blend. Obviously, he mentioned QLC, which has some properties in terms of endurance, which are not as well suited to high churn workflows like Eric has. But what we've done is create an architecture that puts in a very small amount of higher endurance flash in front of that. But the users don't have to manage it, they don't have to see it, they don't even, they know it's there because we tell them it's there, but other than that, it's not really a thing they have to think about.
Whereas before, you had to think about those tiers.
Exactly.
Right, and actually manage them and tune them.
Yeah, and a lot of times the highest performance tier was like SLC, enterprise grade flash, and so one of the great propositions of VAST was coming in here with the consumer type grade of flash and having a file system around it that was smart enough to actually use it efficiently.
If you look at the IT market, technology market in general, I've been studying it for many, many years, storage, on balance would make up, maybe it would comprise 10, 12, sometimes 15% of budgets. There were times when it would bump up more or less, but I'm talking about the macro, hardware, software, services, staffing. Is what's going on with DRAM and NAND pricing today changing the economics of your business, and how are you dealing with that?
I don't think that the current kind of supply crisis right now is hitting us very hard yet. It will eventually. I think what we're focusing on right now is how can we get better dedupe and compression out of what we currently have. What are some of the ways that maybe we could go through and figure out archives that we don't need anymore, what can be regenerated versus what has to persist for over a long period of time. Eventually they will catch up to us, and then we'll have to figure out our strategies around. So in our world, we have multiple levers to pull, right? We could pull the production lever, I don't know, like, don't do as much hair, right? Yeah. That takes less storage or something like that. So that's one lever. Obviously the types of storage we're purchasing and the types of technology we're implementing is another lever. But we have started to see this uptick, and so now we're thinking more like, well, what can we do with what we currently have?
If you think about the workflow of an animated film, maybe you could describe that, and specifically I'm interested in what happens when the storage hangs.
Oh yeah, that's a good question. So when storage hangs, and over time we've become more and more centralized on the storage for reasons of enabling more workflows to come online, but what that does do is when the storage hangs, basically the entire render process and all the interactive processes can stop working. And then the last thing you want is artists outside playing Frisbee Well, they're supposed because everyone's waiting for the storage to come back online. But we've had great collaborations with our partners, with VAST, to try to harden that storage as much as we possibly can. Some of the features that Andy's talking about that were added were specifically to address this concern of, okay, if we are going to get overwhelmed in parts of the storage, maybe just that one workflow is overwhelmed for a bit, but the rest of it is still running. And that has happened kind of more often than not over the last few years, which is more manageable on our end.
Okay, so if storage hangs, you're paying expensive resources to play Frisbee, and it's elongating the time to production.
Yeah.
And the last piece that you were just talking about, of being able to do certain things, sort of parse out the workload, is that a function of AI? My question is, how has AI affected, broadly AI, affected that workflow?
I think on the, as far as the storage component, the new AI tools that are coming in line have been really helpful for us, especially understanding the data. In the past, what would happen was when the storage hung, we'd have to do a detective work to go figure out where in the pipeline this thing happened. Like, what is causing the storage to hang? Is it a problem with the, is it a problem with the file server? Is it a problem with the shot? We don't know yet. But these new AI tools allow us to diagnose that much, much quicker. So that, now, and we're even getting to a point now where we're looking at tools that can preemptively tell us, hey, this thing is happening over here, there's a standard deviation different than what it should be. You might want to look at it before you start hanging.
So, I presume that you guys deal with entertainment, media and entertainment companies.
We do.
Besides just Pixar. Are there patterns that you see across the industry that are similar, and are there things that Pixar does uniquely that you can comment on, that put certain stresses on you guys that you have to accommodate? Is kind of where I'm going with
I think that we do have a variety of different types of media customers. I think Pixar is a little unique in that basically all of the processing happens within a single facility, more or less. There's a lot of customers that we work with in the M&E space where they may have, and there's a big difference in between animation and broadcast.
Right.
And so I think that's one area. There are other customers who use us in similar ways. Honestly, and I was talking to Eric about this earlier, Pixar's more like an HPC farm than it is like a media company in many ways from a technology standpoint. There's a lot of compute, there's users submitting jobs, the I/O is very concurrent. It's very similar to what you might find in a classic HPC environment. In fact, a lot of the tools you guys use are probably ones that are used in HPC environments.
It's interesting.
We pull from all over the place.
So supercomputing is a more relevant show than NAB for you, is that?
For me personally, yeah, that's very true.
So I was going to ask you about NAB, but it's really supercompute is the.
That's the show I'll go to.
That and GTC, I would imagine, right? Which is the NVIDIA version of supercompute. I don't know, Ace. What do you see as the future? I know you're doing your best to build capacity and supply. You must get a lot of phone calls from people. Help me out. I really need this stuff now. So, how do you see the next 6 to 9 months? What are you doing to help your customers like Pixar get through the tough times, and what's the vision of the future for you?
Sure, yeah, a lot of our ability to help relieve some of that pressure comes by working through partners like VAST. So, a little while ago you and I talked with Phil Menez about Amplify, right? And the whole spirit of that initiative is enterprises have all this capacity deployed, but there's probably a lot more you can squeeze out of what's already there, right? If they're using conventional, replication and erasure coding type schemes, maybe eating up half or more of their available capacity, right? You can apply some vast innovations and recover a lot of that and make better use of the resources you already have. Then of course there's kind of like the long-term strategic planning that Solidigm has to do. Do we need a new fab? How do we sort of reorganize our product mix to deliver more bits to the market this year, right? The operations team is constantly fretting over that stuff. Aside from that, I view Solidym's biggest imperative here as continuing to apply a lot of effort to understand what's going on in these workloads and make sure that we're delivering products that serve those well, that we're skating to where the puck is going to be, for example. So if we know that Pixar needs to do, as Eric was talking about, you're modeling stuff, you're applying textures, you're rigging it up, you're rendering it, well, what does that look like? What are the actual I/O demands that places on a storage subsystem? Because that's going to be much different than a couple numbers on a spec sheet. Sure, a drive can do 14 gigs a second and a million IOPS, that's nice. Does that actually matter to what Pixar's trying to do to get the technology out of the way and help the artists? Or is it more about sustained performance and quality of service and those requests and the long tail of latency? I'm sure those really annoy the artists, right?
Predictability is, right.
Yeah, exactly. So
consistency, yeah.
There's a lot of value in a company like Solidigm, which is up the value chain a couple steps, right, from what the artists are actually doing, understanding what they're doing, and making sure that we're building products that serve those needs best.
What about, like, where you do this? You do all this on-prem, some in the cloud, a little bit of both?
Yeah, we're almost all on-prem. And once again, that's because of that latency problem that we have, where we want the absolute lowest latency we can get to the data.
And how are you using, it was interesting hearing you talk before about needing to control the pixels. What do you do with LLMs? Do you do just stuff like everybody does, or are you actually using them,
I think we're probably doing a lot of stuff that everyone else does right now.
Summarizing docs and things like that. And
some of our, we have been fairly early to the game on some forms of AI. So for example, our denoiser pipeline is ML based and has been since 2016. These problems in computer vision and deep learning ML based type workflows is not something that's foreign to us. The key has always been, how do we implement them into existing pipelines that actually give value to artists instead of like just trying to change it all for the sake of changing it all, right?
Right. Yeah, so you're not forcing an LLM, but again, those deep learning and ML pipelines are more deterministic, right?
That's true.
So it's this new world that we're entering. And the reason I ask is because latency matters with respect, but it's not like these foundation models, today anyway, are a fundamental part of your workflow, right? They're sort of additive in some ways, like we all use LLMs, but it's not like driving it's not driving a pivot in your workflow, per se.
Yeah, per se. Yeah, it's definitely something we are investigating all these new technologies that are coming out, and some fit better into the production pipeline than others. New pipelines will come up, and we will have to then pivot some of the storage. Like one of the problems we have as a storage team is the art, we don't have any control over a lot of the art, so they will come up with new ways to do something that our systems just have to absorb and have to understand. Now Pixar started as a hardware company, and so this idea of the collaboration between the hardware technology and the artistic vision is something that's not new to us. It's very collaborative within Pixar as far as like trying to figure out, hey, I got this great idea, now how's this going to affect all the downstream infrastructure? And we go back and forth and try to find ways to incorporate these new technologies.
What is some of the cool stuff you're working on that you can share with us?
Oh man, I think mostly we have a new feature coming out a week from this weekend called Hoppers, which uses some of that new tech. You'll notice it, and I mean everything for us is in the final image, right?
Yeah.
So you'll notice it in kind of the stylistic ways that we render, say, the outdoor environment. Because we control the renderer, we can change physics, and we can add all kinds of new styles that nobody's ever thought of. And that's, I think, where we're pivoting to over the next few years, in my honest opinion. I'm not an artist, so I can't say for sure. But that's where I see a lot of this new technology that we've been working on, both traditional and the newer types of technology that are coming out, impacting the actual pixels on the screen, if you will.
Excellent. Well, Andy, Eric, and Ace, thanks so much for joining me here on this panel. It was really fascinating.
Thank you so much.
Yeah, thank you.
All right.
Thanks,
and
Dave.
thank you for watching. This is Dave Vellante for Rebecca Knight. We're here at the Vast Forward 2026 in Salt Lake City, Utah. We're right back right after this short break. You're watching theCUBE's live coverage, made possible by Solidigm. Thanks for watching.